Hi, this is the project for custom image template enabled platform as a service. So we are a team of four. My friend Huang Chen, Huang Rui, Jiang, myself Shirish, and Nicholas Cappo here are for this project. Uh, the introduction to this project is that with the development of data intensive science applications, there are more and more requirements which are created by different users of different scenarios. These requirements are based on deployment of distributed heterogeneous resources and use of advanced technologies or protocols. That is to say, there are many challenges and limitations through the traditional approaches which are used to deploy the infrastructure of these data intensive applications. Therefore, in our project, we just want to focus on these limitations of state of art infrastructure deployment approaches through a component abstraction model. At the same time, we also want to build like custom templates to store and reuse these templates to solve the problems of lack of repeatable and reusable solution models. So, we have divided this project into four parts, which is collection and abstraction, which deals with collection of requirements from the end user. From the end user, once we receive the requirements, we will head to the part of composition where we will be creating a custom template or a solution from an existing solutions. And once we have a solution for his requirements, we will be giving him the optimal solutions from the list of available solutions, which is done at the part of optimization. Once the user is able to choose the solution, we will be automating the process of deploying the infrastructure in the part of consumption. So that's the four parts of the custom template model. So the part A, collection and abstraction. Here, the part mainly deals with the requirement collection, which is stored in the form of ARI and a resource space. Using these both ARI and resource space, we will be generating a macro operator which is used for developing a custom template further in the future part of the project. So, initially, all the requirements are collected from the user using a questionnaire through a web portal, and we translate all these requirements into a application resource identifier which looks something like this. So we have different questions like minimum bandwidth, isolated network, resource, and if we need an NFV capability, we will try to understand what type of application is developing. We also have questions of explanations on the website for him to understand the jargons and the importance of these questions. So the application identifier, it mainly features the three parts: application, feature, and precondition. This application uniquely identifies the kind of application, and the feature as all the requirements from the user, and the precondition as its details. So the abstraction from the paper was like it has an application which is of say an LAAS, and the feature is computation resources. So the precondition for this is virtual server 12 cores, 6-bit CPU and 16 GB RAM, a maximum processing time of 500 seconds. So we generated this as a layer 2 10 Gbps speed for a precondition, and we uniquely identified this application RID as 10, and the features would be a network and a NFE. So we create ARIs in this similar fashion. So once we have that, we have a resource space generation. We have a data structure of resource space where we have different domains like storage, network, and computation, and they may extend to other domains as well. So resource space generation. In resource space generation, we have, like I said, a network connectivity, a local computation, and storage. A network connectivity may have like NFV, VPN, hardware, and SDN. So these requirements are again known from the questionnaire in the website, and all the requirement details are saved in the constraints. These constraints pertain to the maximum amount of requirements we could satisfy from the our end. So the actual generation would be, we separated all the network requirements, computation requirements, and storage requirements as, say, the resource is NFV, and the R constraint would be virtualized in a dedicated hardware L2 over L3 up to 750 Mbps for Linux system up to 200 Mbps. So combining both of these, we have a macro operator which consists of domain, which is basically in our case network, storage, and computation, and a resource and a precondition. Well, the resource would stand like NFV or VPN or a HDD in the case of storage, and the preconditions are the specifications. So they are combining both of these ARI and resource space. We would basically compare both of these and generate a macro operator, which gives me an app identifier, a domain, a resources, and precondition. So the original abstraction and the actual generation would look something like this, which has, say, network connectivity, VPN, and 100 Mbps. So once we have this macro operator, we go to the next part of custom template. While the part A of the database is something like this. We have users, which we say different users who log in into our system. We have an application RI, which is ARI. We map this with an unique ID, an application ID, a feature and precondition. And in the resource space, we have a RID, which is again unique. And we save the domain, which is network, storage, and computation, resources, constraints, and resource cost. Similarly, the other user apps data and macro operators. The custom template lifecycle, part B, composition. So in the first part, we have a macro operator that is created from the user's requirement by merging ARI and resource space. So once we have a macro operator, we can use this to compare with the custom template catalog. There are possibly two outcomes, a 5A and a 5B as shown in the picture, which is we can have an existing solution from the list of solutions, or there are no solutions at all. So that's the part of composition. So during the comparison, we use the new macops created in part A. So if we have a basically the abstraction would look something like this, which is domain, resource, and precondition, and I will compare this with the custom template catalog, which also has domain, resource, precondition along with the R constraints from the resource space. And if there are no solutions available, we create a new solution from the existing solutions. If there is an available solution, we give that to an user. Initially, if the catalog is an empty one, so we just create a custom template and save the solutions to custom template catalog. The abstraction looks something like this, which is we have domain, resource, constraint, and precondition. The constraint is coming from the R space. Domain, resource, and precondition are coming from the macro operator. Now, both these tables are compared using an algorithm. What my algorithm says is compare the requirements with the existing solutions. All we need to check is if their solutions are close or exactly the same. The target is to meet the same requirements, but even if it's close by, we would provide him with those solutions. So based on a threshold, the solution close to requirements is found from the existing solutions. Now if there is no match, we will create a custom template from these solutions. Now, the abstraction is when we give the template solutions, it would look something like this. We add a unique application identifier to uniquely identify the application and give the solutions to the users.
All right, so here we show the demonstration of what our website would look like. We have our About Us, and here we can generate a custom template. So we'll go ahead and get started. First, we need to log in. And here we can go ahead and get started in creating our custom template. This first part, we ask general questions about the application that the user will be trying to create. So the first one, the main function of our application, we'll use a test case that we used previously. We'll say data processing. And the priority with this would be obviously computation if we're doing processing. And we'll be doing genomic sequence. And then we will be transferring approximately 10 GBs of data. Over here we see the question explanations that we talked about previously. And here we'll see what is priority. We can talk about why we would want network storage or computation as our priority. So we'll go ahead and hit next to our network connectivity. Say we need this. They also have the option of saying unknown if they do not know, even without the question explanations. And so we can go ahead, add some unknowns here. And we'll say we want this in a very short amount of time. So we expect that the data will be about 1 TB of data. We will want local storage here for this, and then HDD is fine. And then we will want backup storage just in case. So here's the computation part as well. Unknown for a lot of these might be an option that would be used, and then 8 GB. Alright, so once we have submitted it, we get our 3 custom template solutions that the user can then select from. We have our green basic plan features, our popular and recommended plan in gold, and then a red here. So we'll go ahead and talk about the next part here in the optimization part. So in this optimization part, part C, we talk about all the different solutions that we get from our macro operator being compared to the custom templates. And here we must select, we will select 3 as we showed before, and then we give it to the user to decide which one they would like the most. Originally we would only take into consideration the one that used the least amount of resources, but now we have implemented this idea of cost. And each part of our resources, and whether it be networking, storage, or processing, each comes with an associated cost that is in the database. When the macro operator is generated, we get a total cost for the entire what the entire template would be. We compared a lot of the costs of what Amazon currently does for their web services, and then for network, which they do not charge for, generally, specifically, we implemented our own fees accordingly. And each time the total cost must be calculated because sometimes resource costs do change, and so this needs to be checked each time. As for our green, it uses our least amount of resources, and we assume that this is also going to be the best price because the least amount of wasted resources would give us the lowest amount of price. And the red is the template with the most amount of price, which would give us the fastest computation and priority, as well as the greatest amount of resources. And our goal, our preferred choice, would be somewhere in between the two of those. Once it's selected, we can move on to the deployment phase.
So the final part here is the infrastructure deploy. And here we want the deploy to be fully automatically. Just by click the submit, we will have just connect the submit here. We will have our infrastructure already been deployed in this slice. We can see here we have two slices created here. One with the controller and one with the hoster. And then we get into the hoster, and we can see what previously we pre-order in the website is already being deployed, and the deploy process will take like 5 to 6 minutes here. Here we have two nodes, two hosts, and one switcher, and on another slice, on the other slice, we have a controller, and in the controller, we also have one node. Maybe it will take some. Okay, we also have a controller here, and you can see it has public IP. So the deploy process is fully automatic. It have been 4 steps here. First, we extract information from the custom template catalog using a Python SQL. It is an open source Python library. And then we create a new slice in the GENI project. This is being done by using the Omni command line tools. And then we deploy computational infrastructure using an open source Python library called GENI. And then finally, we configure the network configuration, which is used by OpenFlow. And this 4th step is fully automatically. And you see here, in the traditional way, if we want to deploy infrastructure, we need first create a slice, and then drag and drop the node we want, and connect it. Okay. And so here is this UI is not realistic in our case. So here we're using the Omni command line tools. Just a 3 line here. First, create a slice, which is named controller. You can see here in our GENI portal. Another is called Omni create slice host. And then this is the GENI configuration of my file. You see, this tool is my portal certification and key, and this is my username. This is public key, and this is my project. Okay, and this is some GENI Python library, which is used to reserve resources in the GENI lab. I don't want to go into detail. Okay, and this is the respect which is generated by this Python file. And after we have this, okay, now after 7 minutes, you can see our resources already being deployed. You see the host 1, the host 2, and the switcher. Go to the website, connect to your template, and the login information will pump out. And also, we have a key file and an infrastructure for the user. Okay, then first download the key, then download the instruction. We follow the instruction to store the key in our computer. Okay. First, make SSH, and then move the key to the SSH folder. And then we change the file permission. And then we add the key into the SSH gender. Just copy this and paste. Okay, and add this key. The password here is 19880813. Okay, the key is already being added to my computer. So now we can log into our host and to check the network configuration. Just copy this and close it. Yeah, now we already logged into the host 1. And let's try to ping to host 2. And you see, they have already get connection, just using our template. Okay, and then we can show how to. Okay, we can log into host 2 and ping to host 1 again. You see, you can see they already have connection. Okay, I think this is the demonstration of our custom template video. Thank you.